33.3. In this video, we're going to talk about the enthalpy change in exothermic and endothermic reactions. We're going to give you some example and also the applications of this reaction. So in the last video, we talked about the enthalpy. Enthalpy, it is the heat content, okay? It indicates the energy content. However, we cannot measure it directly because it includes Pe and Ke. We cannot know how the particles, how close they are stick together. We don't know the potential energy stored between the particle. So therefore, one thing very important you have to remember is, okay, they cannot be measured directly. However, okay, we can measure the enthalpy change. In an open system, we know that the heat change that we measure, okay, that will be equals to the enthalpy change. Okay, so enthalpy change will define it as, okay, the enthalpy of the product minus enthalpy of the reactants, because that is the changes. Okay, we know that, okay, that will be a new value minus old value. Or what means by new value minus old value? So when you have a reaction like this way, okay, so this will be the products. That will be the new values of the enthalpy. So we use the new value of the enthalpy of this C minus the enthalpy of the reactant A and B. Okay. However, we have mentioned, okay, we cannot measure it directly. So therefore, actually, this equation is just a definition telling you that, okay, the product minus the reactant. But we can't really have an enthalpy of products, and we can't really have the enthalpy of reactants. Okay, but you have to know that that will be product minus reactant. So if we present this idea graphically, okay, you can see something like this. So enthalpy level diagram, okay, so that will be a enthalpy level. Okay, we just have a y-axis here. Okay, so because we don't know the reactants, okay, the enthalpy of the reactants, how much value it is, so it will be very okay for you to randomly draw a line, say this one. Okay, so this will be the enthalpy of the reactant. If I want to say in the process, okay, we are having exothermic reaction. Exothermic reaction, that means releasing energy. So the enthalpy of the reactant, they release energy. The energy level must be going down. Okay, must be going down. So therefore, we have a new enthalpy of products here. So if we're using enthalpy change equal to enthalpy of product minus enthalpy of reactant, we can see in this case, product is having less enthalpy than the reactant. So that means that you have a small value minus a large value. So in this case, okay, we can see that it will be a negative value for the delta H. So if it is a negative value, that means that it is a exothermic. Okay, negative value, that will be an exothermic reaction. Okay, so we do something very similar in an endothermic reaction. If we are having an endothermic reaction, this time, okay, we just random draw the enthalpy of the reactant. Okay, I draw it right here, let's say. So that will be the enthalpy of the reactant. As we know that that will be an endothermic reaction, that means it absorbs energy from the surrounding. So therefore, the enthalpy, okay, it will going up this time. So we'll have a enthalpy of product which will be higher than the enthalpy of reactant. So this time the delta H, again it will be the, again that will be the reactant, or the product minus reactant, product new value minus the old value. But this time the product is at a higher level than the reactant. So therefore a large value minus small value. Okay, so in this case, we will know that it will be a positive. Okay, so if the delta H is positive, then that will be an endothermic reaction. Okay, so just one thing I want to draw your attention is, okay, feasibility of a reaction. That means if you let the reactions right there in a room condition, is it easy for it to occur? Okay, the more negative one, the reaction will be more feasible, because we know that the excited, okay, the high energy things, normally it will tend to go to a more stable levels. Okay, that means they tend to release the energy to the surrounding. So if it is a negative value, the reaction is a negative values, okay, the FOP change is a negative value, more likely, okay, it will occur on its own. However, there is another concept called activation energy. You learn it in book 5, okay? But right now, we just consider that if it is a negative FOP change, more likely it will occur, okay? So this slide, okay, you may need to know that, okay, the FOP change, if it's negative, that will be exothermic. Positive, that will be endothermic, okay? So exothermic reactions. So I'll give you one example. For example, we have zinc put into copper-2 sulfate, and then we'll have a copper formed, and the zinc will become the iron. The reaction for this one, it should be a displacement reaction. So if you take a closer look at the pictures on the right hand side, you see that the copper-2 sulfate original temperature is 22 degrees Celsius. If you put the zinc in it, okay, so you can see that it raised to 37 degrees Celsius. So you can see that, okay, the mixture becomes warm and heat is given out. So the heat given out, it get to the thermometer. So the temperature, okay, it go to the thermometer. Okay, go to the thermometer. So therefore, the liquid inside thermometer absorb the temperature. So the temperature, the liquid inside, it will expand. The temperature will then increase. So these are the features of exothermic reaction. And like what we have mentioned just now, when the solution is right there, okay, it is exothermic. The heat will go to the surroundings. Okay. The thermometer, okay, is part of the surrounding, so therefore the thermometer will absorb the energy given out by this system. So like what we've mentioned just now, if you got a reactant like that, exothermic, it will just reduce the energy inside the reactant. So therefore the new product's enthalpy, it will going down. So if we have a small value minus large value, then that will be a negative value. So, okay, remember, delta H equals to HP minus HR. P is a large value. P is a small value. Small p minus large R. So therefore, this time it will be a negative value. So more negative, we say that it is a more exothermic reaction. Okay, more negative means more exothermic reaction. So what kind of example exothermic reaction do we have? Basically, okay, combustion, it must be exothermic because you find that during the process, it will release heat energy. Okay, so when we like burning hydrogen, burning methane and the town gas, so all these, it will be exothermic reaction. Heat is released. Second one, okay, that will be the neutralization. You see that NaOH, HCl, when they mix together, when they form sodium chloride and water. This one we learned it before. It is an exothermic reaction. All kind of neutralization is exothermic reaction. No matter you are having like copper-2 oxide react with the sulfuric acid or the other things. Okay, so precipitations, okay, that would be also a exothermic reaction. So we do learn that, okay, the metal ion react with the hydroxide ion when they form metal hydroxide. So this is also an exothermic reaction. The precipitation is an exothermic reaction. So you look at this one, you can see that actually the silver ion and chloride ion come together and stick together to form a solid. So in this process, okay, normally that would be an exothermic reaction. So other exothermic reaction, you have displacement reaction like previous one we mentioned. We also have one in the public exam always asked, okay, that would be putting calcium oxide into water. So actually putting calcium oxide, dissolving calcium oxide into water, that is also an exothermic reaction. We have applied these exothermic reactions in a self-heat lunchbox or beverage. Okay, so you just need to add some water in a packing or things like this, okay, and then they will generate a lot of heat to heat up this, or maybe the food, maybe noodles, maybe drinks or things like that. So when you put calcium oxide into the water, they form calcium hydroxide. In this process, that will be an exothermic reaction. So you may say, oh, Mr. Wong, it is so difficult to record, okay, which one is exothermic, which one is endothermic, okay? Actually, you have some concept in terms of bond breaking and bond forming. It can help you a bit. But before that, okay, you just watch one video. So it's so difficult to explain in words, so I make a videos for you in the school, so you can have a look of it first. That one is a exercise. So I think it's quite close to related to the bond breaking and bond forming and energy flow. You can have a look right now.
Okay, so this video is just help you to memorize how bond breaking and bond forming easier in related to the energy flow. So you imagine these two particles, okay, these are molecules, okay, we've got two particles here, two atoms. So if you try to separate them, okay, that will be bond breaking. So imagine, okay, the energy just like your air, okay, breathing in and breathing out. So this one, okay, you do this action, you just have to breathe in, right? Naturally, you breathe in. So you try to separate the particle apart, okay, it will be breathing in, okay, energy taken in. So this one will be energy taken in will be endothermic. So this one is endothermic. So in other way around, if you have bond forming two particles, okay, come together, okay, that will be energy release, like you breathing out. Okay, so this one bond breaking, energy taken in, endothermic, and then bond forming, releasing energy, that will be exothermic, breathing out. Okay, so you just think like that, okay?
Okay, so when atoms, okay, you see that. Okay, so when you have the hand, okay, try to have two atoms. You imagine these are the atoms. These are the atoms, okay? So when atoms, okay, come close to each other, okay, that means you're bond forming. Okay, you're forming some bonding, okay, in between the atoms, okay? So naturally, when you do this exercise, okay, you have to breathe out. So imagine the air, okay, that will be part of the energy, okay? So breathing out, that means releasing energy. So that will be an exothermic reaction. Just help you to memorize better. So how this one can help, okay, to memorize, okay, reaction. So you just use the concept just now we have. When we have two aqueous ion, silver ion and chloride ion, when they come close together and then they form a silver chloride solid. So obviously you see that two particles, okay, they come together, they form bond. So purely they're forming bond. So in this process, okay, we will know that bond forming, it will be a exothermic reaction. But on the other way round, okay, if you try to bond breaking, say for example, okay, you have two particles very close to each other, and then this time you try to move away, okay? So you break the bond, okay, to separate the atoms apart. When you have bond breaking, like melting, like vaporization, when you have something in solid state, okay, you try to make it into liquid state, the particle have to be apart, is that right? The particle have to separate apart. So this one is a bond breaking process. So if you imagine you're breathing, okay, when you separate the things, you stretch your arm, air will breathe in, is that right? So just like absorbing energy from the environment. So when you have bond breaking, that will be endothermic reaction. I highly recommend you to do this exercise. You feel the two fists, okay, your fist, okay, moving away, okay, you're breathing in, the moving out together, then you will breathing out. That will be in related to the energy flow and the process, okay? So that will be some concept about bond breaking and bond forming related to the exothermic and endothermic reaction. So now we come to more example of an exothermic reaction. So you can see that in this case, when we have gas, they become liquid. That means, okay, the particles are coming closer together. So we are having bond forming. Like what we've mentioned before, bond forming, energy have to be released, okay, energy release. So therefore, that will be an exothermic reaction. So from gas to liquid, that is a bond forming. For liquid to solid, we can't really say bond forming, but the particle come close together, okay? Bond forming can be, okay? So liquid, okay, go to the solid, okay? That would be a bond forming. So this one just remind you that would be a physical change, okay? Physical change. So in the process, okay, that will be an exothermic reaction. So more sophisticated concept, okay, so when we have gaining electron of the chlorine atom, let's say chlorine atom, so when they have the electrons, they put these two things together, they become a chloride ion, okay, chloride ion. So this process actually, we are having the chlorine atom and electron bring close to each other. So therefore, in this process, this is also an exothermic reaction. We also have some other exothermic reactions like Thermite reaction, like other reactions. So you can just scan this QR code, then you can see some reactions, okay, or how exothermic it can be, how much heat energy can give it out. I highly recommend you to have a look of these two links, okay, to know more about this kind of reaction. So next we will talk about endothermic reaction. This is a very interesting experiment, okay, but can't show you right now, okay. You can take a look of the QR code, okay. So basically we just put ammonium chloride and hydrated barium chloride together, and then, okay, we are on piece of wood, we add some water on it, we put this beaker on top. Then this one, okay, is a highly endothermic reaction. Then it will absorb energy from the surrounding, including the water, the energy from the water. So if they absorb the energy from the water having less and less energy, the water will then turn into ice, okay. So this one you'll find that, okay, the beaker can stick with the wood because the middle, the water turn into ice. Okay, so this one is a very interesting experiments. So endothermic reaction, just like this one, the system, okay, they will absorb heat from all around. Okay, we absorb heat from all around. Okay, so if you have the reactant like this, after absorb the energy, they get more energy. So we have a higher enthalpy like this. So we'll see that, okay, this time the delta H with a larger P minus smaller R. Okay, so therefore, if the enthalpy change is positive, then that will be an endothermic reaction. Again, more positive, more endothermic, absorb more energy from the surrounding. So the feature of enthalpy, endothermic reactions, okay, that will be the mixture will become cold. When you hold it, you feel cold because it absorbs energy from your hand. Heat is taken in from the surroundings, okay, and the temperature of the mixture will also decrease. Okay, so example for endothermic reaction, we have cracking, okay, because we need to break the bond, okay, we need to break the bond, okay. So bond breaking, you have to absorb energy. So cracking would be a good example for endothermic reaction. Thermal decomposition is also breaking the bond, okay, it is also bond breaking. Remember, bond breaking, okay, bond breaking, okay, you like separate the particle, okay, you have to breathe in air, okay, so therefore that will be an it will be an endothermic reaction. So this is a setup like we have a calcium carbonate, okay, you heat up, okay, you have to absorb energy to break it, okay, to generate the carbon dioxide right there. So we also have in the exothermic reaction, we did say that calcium oxide add in the water is exothermic, right? But it is not necessary putting every kind of salt in the water is exothermic. Some of them will be endothermic, like this one, okay. If we put ammonium nitrate into the water, okay, so this one, okay, it is a endothermic reaction. It will absorb energy from the environment, okay, so that will be an endothermic reaction. So other examples, okay, like the other way round, if you try to separate the solid or the particle in the solid into liquid, that means you break up the bond, okay. So in the process, melting and vaporization, that will be a bond breaking, separate the atoms apart. That will be an example of endothermic reaction. And for the sodium atom, if you have a sodium atom, you lose electron in the process. So actually you break up an atom, okay, into ion and electron, okay, because you separate them apart. So therefore this is a bond breaking as well. So that will be an endothermic reaction. So example right here, okay, if you put calcium into water. Okay, put calcium into water. That will be a lot of heat given out, a lot of bubbles given out. That will be an exothermic. You burn petrol. That will be an combustion, right? Combustion, it must be energy release. That will be exothermic as well. Negative, negative. Or cracking, okay, you have to break some bond between a heavy metal. You have a large hydrocarbons, you have to break bonds, okay, so therefore that will be endothermic. That will be absorb energy, positive. Reaction between copper-2 oxide and sodium hydroxide, that would be a neutralization, right? Neutralization is heat releasing, exothermic. So decomposition, you have calcium carbonate, you break the bond, okay, to form calcium oxide and carbon dioxide. So this one is endothermic. That would be positive. Last one, okay, you have lead-2 nitrate and sodium sulfate. You're having Pb2 plus react with the sulfate ion to form solid. It's a precipitation process. Precipitation. So precipitation, you have particle come close together. Okay, you bond forming. So this one is exothermic, negative. Okay, so application for this. Okay, so we have hot pack, and also we have hot pack. We also have cold pack. So basically, okay, hot pack. Okay, we have dissolved calcium oxide in water. Okay, that will release heat, so we can use this one to keep warm, to treat muscle fatigue. Okay, so for the instant cold pack or ice pack, okay, it will just imagine. Okay, we will have like a bag. Okay, outside, okay, we got maybe ammonium nitrate. Okay, we got a lot of crystal there, and then inside they got water, a small bag of water. What you need to do is just break this bag of water, so the water will come out and mix with the ammonium nitrate. So remember, okay, you have to memorize what kind of chemical in the hot pack and ice pack. So we did mention, okay, dissolving ammonium nitrate into water, that will be an endothermic reaction. So they will absorb energy from their surroundings. So when you hold it, okay, you'll feel cold. So we use this one to treat the sport injury if you have like muscle cramp, or you just like sprain your ankles. Okay, we use the ice pack to help. Okay, so we also use this to reduce swelling. Other than that, okay, we have like hand warmer. Okay, and hand warmer, okay, will also an exothermic reaction. So in this process, actually inside we have a rusting process with iron powder. We put salt, activated carbon, so the iron will react with the oxygen and water in the environments. So remember 4, 3, 2, and 2. Okay, and then you have a rusting process occur. Okay, so this will be the hydrated iron 3 oxide. So in this process, they will be releasing energy out. Okay, the energy going out. So you hold it, you feel hot. So quick summary of the exothermic. Okay, it is a heat given out to the surrounding. We know that the enthalpy of the product is less than the reactant, because reactants releasing energy. Okay, so the products will be less enthalpy. So this one is a small value, small p minus large r, so that would be a negative value. So we will have like combustion, precipitation, acid, alkaline, and also all kind of bond forming, bond forming process. That will be exothermic reaction. Okay, the other one, okay, that will be endothermic. Okay, heat will take it in from the surrounding. Okay, the products is absorb energy from the from the surrounding. So you have a larger p minus smaller r, so that will be a positive values. Okay, remember, more positive, more endothermic, more negative, more exothermic. So we have like bond breaking process, like cracking, cracking of petroleum fractions or thermal decomposition of calcium carbonate, that will be a bond breaking. So the exercise, remember, practice a little bit more, okay? So bond breaking, that will be endothermic. You have to breathe in, okay? And then bond forming, okay, two particles come together, that will be a breathing out process. That will be an exothermic reaction. The applications will have like heat pack, cold pack, okay, or hot pack, ice pack, whatever it is, okay. You also had hand warmer, okay. So these are some general idea about exothermic and endothermic reaction. That's all for this video. A long one, I know that. Okay, bye bye.